Now, and we begin from this page 45. We begin from page 45, and we first look at this truss. This is a simple truss because it is a rigid body. So this is because it is a rigid body. Now let's say we have 3 points, A, B, and C. So we want to look at how many members do we have and how many joints do we have. And as I mentioned, that these are member, and I'm not sure whether I talk about it. That this is a joint. It's okay. So a rod is a member, and all members are two force bodies, and we have some joints. Okay, this is a joint. This is also a joint. Is that okay? So let's if you get this if you can get these two words, that we go to the simple truss below here. So for this triangle, then how many members do we have? We have 3 members, and how many joints do we have? 3. Now we want to make the truss a bit bigger, so we put it like this. And we have points D here. So after we put point D, how many members do we have? How many members? 1, 2, 3, 4, 5. So we have 5 members. And how many joints do we have? How many members do we have now? We have 1 joint here, 2 joints, 3 joints, and 4 joints. And so we have 4 joints. And we want to make it even bigger. So we put like point E here. For this truss, how many members does it have now? 1, 2, 3, 4, 5, 6, 7. 7. And how many joints? And then we have 5 joints. So do we have a relationship between number of members, which is M, and number of joints, which is N? Do we have a relationship between these two? So we have so you know how to find the relationship, but let me write down the results. So M is equal to 2M minus 3. Is that okay? So if N is equal to 3, then M is equal to 3. If N is equal to 4, and M is equal to 5, and so on. Now, you may ask, what happens if we have if the relationship between M and N is different from this? So if we, for example, in this shape, and we have how many members do we have? And 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 members, and we have 5 joints. Right. Here we have 8 members, and we have 5 joints, and m is greater than 2m minus 3. It's okay. In this, so can you get my meaning? That we have 8 members here, 1, 2, 3, 4, 5, 6, 7, 8, and we have 5 joints. 5 joints at 1, 2, 3, 4, and 5. We have 5 joints. So in this case, in this class, that m is larger than 2m minus 3. So, and what happens? Okay, let's take an example. If we have a force F here going in this direction, okay? If we have a force acting on this joint, so this part will have compression, and this one will have tension. So let's say A, B, and C. On A, B, and C. So we have A, B will have compression, and BC is equal to tension. It has tension, but of course we know the compression here, the tension here, and then the is equal to the sum of these two forces is equal to F. But what is the compression here and what's the tension here? We cannot know, because now we have a equation. We can get an equation like this is let's say we have TAB and we have TAC, and of course we know TAB plus TAC is equal to F, but can we get TAB and TAC from one single equation? We have two unknowns, right? These two are unknowns. We don't know the compression or tension in these two, but we have only one equation. We have two unknowns and we have one equation. So we cannot get TAB, we cannot get TAC from one equation. So from here we have cannot get cannot determine two unknowns in one equation. We have, because of course we know the force here, and we know there is some force here, but we have only one equation, so we cannot determine two unknowns in one equation. In this case, we also call this statically indeterminate. So if we have a truss with m is larger than 2m minus 3, that's it is we call this statically indeterminate. Let me remind you that wait a minute. Make it smaller. Statically indeterminate means we cannot determine the forces. We cannot determine all forces. It is in equilibrium, okay? It is in equilibrium, but we cannot determine all the forces using the statics equations. Yeah, thanks for the reminder that this should be TBC. Sorry. Right. Yeah. So in a trust that for the trusts I give you that you to determine the forces that they have always this relationship that m is equal to 2m minus 3. So number of members is m and number of joints is n, and m is equal to 2m minus 3. Now, so I will go on with. So after you have finished writing this, I will go on to the next page. So if you're finished writing this, I will go on to the next page and so we have a something like an SOP. Oh, by the way, who knows what is the full name of SOP? S is for standard. O is operation. P is for procedure. We have a standard way of dealing with. We have a standard way of working on problems with trusses. Okay, standard operation procedure. When we say SOP, usually when we say SOP, it means this one. So we have a standard way to work on trusses. Okay, we have a SOP to analyze trusses. We have two steps. We have two steps. The first step is rigid body analysis, which is identical to chapter 4. So we treat, here we have the problem like this. We have the problem, and we have the problem like this, and the distance here is where? Wait a minute. This is the D1 and D1, and this is D2. So as in chapter 4, we say this is a rigid body. We say this is a rigid body, and we draw, this is, what kind of joint is this one? At A, what's this joint? How do we call this? This is a pin joint, okay? This is a pin joint. And what's this one? Roller. Very good. So if you forget or did not get my point, so go to page 37. Okay, these are the typical types of joints we deal with. It's okay. So let's we will see these joints many times in this course. Okay, so these are page 37. So on the left we have a pin joint, and on the right we have a roller joint. Pin support and roller support here. So for pin support, we can rotate, but we cannot move left and right. So we have AX, and we cannot move up and down, and we have AY. Now on the right we have a roller joint, so it can be moved left and right. So we do not have force here. As long as we can move here, then we do not have a force. We cannot move up and down, so we have a force By here. So we cannot move up and down, so we have a support. We have a support force here. Now, so we have from here we can. I know you can do this, or you need to know how to write these three equations. So before you write these three equations, then what should we write on the left? Summation fx, right, is equal to 0. And how about the second one? How about the second equation? Summation fy equal to 0. And the third one is summation m, this is m, should be ma equal to 0. So you can get RAX, RAY, and RB. Is that okay? I think these are the same as you work on problems in chapter 4. Then you can get RAX, RAY, and RB. Now in chapter 6, we want to go further. And we want to go further in our problem. So in the textbook we have two methods in the textbook. One of them is called method of joints, and the second is called method of sections. In the class I will teach this one, but you can use both methods in examination. I will teach the first one. The two methods are quite similar, actually. Now, from here we work like this. We divide the truss into two free bodies. Let's say free body 1. Wait a minute. free body 1 and free body 2. Sorry, how should I work it? This is free body 1 and free body 2. Free body 1 and free body 2. Is that okay? We cut the we cut any of them. Now we cut AC, but we'll work on the others. So we cut we divide this the contrast into 2 free bodies. Which free body 1 is here and free body 2 is here. Now, if we do nothing, now we look at the figure on the right. If we do nothing, if we cut this free body into 2, so and we have P, right? We have the force P here. We have the force P here. We have the force P here, and then we cut it into 2, so it will go like this, right? So can you see what I mean here? So so we have this one, and now we have the force here, and we take this out, so it will go this way, right? Let's say we have originally we have this one. At the start we have this one, right? And this one is a pin joint, and we have a roller joint. So if we add one force here, so it will go like this. So it will go to the right, and then that will go down like this, right? Okay, get it. So to make it to keep the original shape, so we add 2 forces to we add the force here and we add a force here to put it back to the original shape. Okay, we have this shape. If we have P, it will go down to here. Then we in the first step, okay, in first step we will go down to that, right? In the first step we have this one, and to go back to the original shape, we can do this. We add forces here, okay? So we pull it, and then we go back. Then it will go back to the original shape. Okay. Now we have added 2 forces here. Now by action and reaction, this is action, and now we have reaction. Okay. I'm sorry, I should put it like 3 here. So we have action and reaction here. So we have so on this on the second free body, that we have a force going on. And the question now is, how much force do we need to put in step 2 to go back to the original shape? Because if we put too much force, then it will go in another direction. So the problem is, how much force do we put in step 2?